Oh, wow. So apparently I didn't have my mic on. I don't know if anybody's watching, so let's start again. Okay, let's get started here. Hopefully I'll edit that all out. Hey, King San. Thank you for dropping by. Okay, uh, because my mic wasn't on, let me do this again. Okay. Last time what we did was basically we implemented the base stuff we need for rollbacks, which includes saving and restoring game state. Lets us jump back into the past basically, and then once we have input that from the other player, we can resimulate up to the current time, which corrects for any desynchronization that may have occurred over time. And of course, we had to unlock the game simulation from that whole like deterministic lockstep synchronization because we need to be able to simulate in every frame to make sure there isn't any pauses, so it feels comfortable for the player. Anyway, but then we had a problem where if the two clients uh, get out of sync time-wise, so one falls behind the other, it can get so far behind that it gets outside of our rollback window, and we're unable to jump back so far to resimulate a lot of frames. Honestly, we could do that, but it ends up being a problem if we resimulate too many frames in one go, because we can actually drop frames and cause even further desynchronizations. The other issue is we just don't want to be that far ahead anyway, because one player will be so out of sync with the other that you'll just see constant rollback effects. Like the character will be jumping around the screen and stuff. We don't want to do that. We want to correct for that. So this time, what we're going to do is we're going to limit how far one player can get ahead of the other. This is basically going to be our max rollback window and the max number of predicted inputs we can support when we get to that point. And after that, we're going to have to like deal with making sure both players are basically at the same frame at the same time. And it's basically compensating for, we have to compensate both for network latency there and be able to predict how far our game has ticked ahead the other. Yeah, while compensating for latency. And we have to do it equally on both sides. Okay, that's what we're going to do this time, but yeah, let's get to it. So right now, how are we going to like limit the frames, right? Well, we want to have a max rollback window. I think did I already add a max rollback window? I don't think I did. So that's what we're going to have to do this time. So right now, if we look back at our synchronization code, where is that at? We should have a little bit of sorry, I'll have to look for it real quick. Yeah. Okay. When we were in lockstep mode, we actually limited our frames already, right? We limited it by the number of input delay frames we supported, but this time we want to limit it by the number of rollback frames we support. How to do multiplayer? That kind of like large scale multiplayer stuff, I think, is a little out of my skill range or experience, probably, but it'll be fun, I think. Let's see. Actually, simulating an entire universe seems insane. Or just a solar system. I don't know how big KSP2 gets. Okay. Anyway, yeah, so basically this whole update next frame thing, we temporarily just allowed it to keep going. This time, we limit it by some frame amount. So let's say, just for example, just as just brainstorming here, we want something like our current frame count to be, if it's ever greater than the latest network frame from the opponent. Obviously, we want to let it go some number of frames ahead. Let's just say just 10 off the top of our head is a random number, right? If it's ever greater than 10, then we'll just stop the game. This may not be the right value, but I'm just brainstorming here. Basically, you can think of it this way. If one side pauses because the frame drops for whatever reason, or someone's dragging the window around, the other side's going to get, say, like X number of frames ahead. In this case, 10, right? So I'm at frame on my side, which hasn't paused. I'm at say frame 20. I get 10 frames ahead, so I'm at frame 30, but my opponent is still at frame 20, right? Well, I would have to jump all the way back to my last confirmed frame from them, which say was 20, and then resimulate the last 10 frames, which is going to cause a lot of desynchronization, right? Or a lot of inconsistencies. And it's going to happen every frame. We're going to have to simulate. Every time we get input from the opponent, we're going to have to resimulate those 10 frames because I'm constantly 10 frames ahead. This is just like, but the problem is if I get too far ahead, I won't have enough inputs to resimulate all those frames again. We're just going to be completely desynced. Okay. So we're just saying 10 here for now as a placeholder. This might have a one off by one error actually, and I might have to fix it. But sorry, bear with me for a moment. I'm gonna go up here and add some. We have some constants up here. I'm gonna call this max rollback frames. Let's just say 10. And this is gonna limit how many. Whoops. It's gonna limit how many frames ahead we can go. Again, this check is a little placeholdery. And of course, we could do something like this. We don't actually need to do this. We can do something like this. Well, actually, I don't want to actually. Yeah, this is fine. This will just check to see if we can roll back or limit how far ahead we can go. Okay, so we might not have that issue now. You probably saw me testing the game and it desyncing. Okay, let me minimize one of these windows. Oops. No, but still desynced. Give me a second here. Okay, so actually, right now, we don't have any really debug information to follow what's going on, right? And actually, I'm going to do one more thing so I can see the top of the window, because it's going to allow me to try some stuff. Okay. I'm just going to like lower the window a little bit, so it makes this a little bit easier. Okay. All right, so you can see the net frame here and the frame count. The net frame is what we're getting from the opponent, right? It's probably going to be really difficult to, but you can probably see when I drag this, the net frame pauses, right? Whoops, that was a lot of windows closing. Yeah, so we crashed here because of we probably tried to read from a buffer out of memory, basically, outside the memory range. So you can see frame count here is 586. This one's 584. Net frames here is 0 because we don't really know what the frame is because of this crash. But let me remove that limit and see what happens. Oh, this is actually wrong. Frame count, it should be less. Okay. I don't know why it was working there. That's really strange. Okay, let's do this again. Okay, we can see we're simulating, and we're desynced now, right? If you look here, my frame count is 226. Up here, it's 237. So this is no good, right? It's clearly no good. Let's go back, and you can see I've gone 10 frames ahead, and this is, well, actually 11 frames ahead, and it's outside the range we can keep syncing, but never fixes, right? it's because we don't have inputs to actually fix it, because we've gotten so far ahead that this side is no longer getting inputs from this side, right? It just, because either through packet loss or whatnot. Probably could fix that by like resending old inputs and causing it to go ahead. That might be something we do in like extras later, but yeah, you can see how this problem can occur. So because I'm 226 here, the frame we got from them is 238 minus 10 is gonna be 228. That's gonna be too far ahead in that, like, remember we made that packet loss compensation thing where we had like 10 frames per packet. Well, that's outside that window, right? So we've now lost enough frames where, like, sorry, we've gone so far ahead on one side where it's outside of that like buffer window. So we just don't have inputs, right? 'Cause either a packet got dropped or something. So we want to be less in that window, at least for this example, because we're not doing any kind of like resending of packets. So I mentioned the off by one error thing. So this probably will fix it. Hopefully. So yeah, we're running just fine. Oh, we're still out of sync. What do we got? 213 head. Okay. So what's going on here? Let's try to reduce this even more and see what happens. Okay, we're running just fine. Oh, I don't like Windows sometimes. Okay. So we got how far ahead are we? I wish I could add a pause here so we could see. But even when I drag the window, which pauses the game, oh, I really don't like that. So if I just drag this around, it does that. Oh my god, Windows. Really? Can I turn that gesture off somehow? I really don't like that. Okay. So, oh, we've desynced again. And yeah, you can see one side is 1508, 1503, so it's by 5 frames. So somehow we don't have input for the right frame. It should include it though. Like, look at this side. So our frame's 1508, this is 1502. That's within that 10 frame window. Are we resending the inputs? Let's double check that. So we should be sending those inputs every frame. Let me check my log here. So the latest network frame, it's interesting. The latest network frame was 1497. That's way behind. Let's try the host. Okay, the host got 1503, 1502. Okay, that's interesting. You know, I wonder why so basically the host can't move forward, which makes sense. But I'm kind of curious. They should be sending. We should be getting packets from the host. So what's going on here? Yeah, it should be sending this every game loop update. Why aren't we receiving anything? Oh. Well, we set input history here. Yeah, we're ticking this every frame, so there shouldn't be issue here. Huh. Let's connect to... Hold on 1 second. Let me attach the process, see if I can detect what's going on. So we should be sending inputs, which we are. Okay. double check who we're sending. Of course, it's gonna crash. Just give me a second here. So send package. Yeah, frame count 1509. Maybe it's outside that window we need. We do have a bug here. Well, this is part of the stream where I fix a bug. I might do fighting game 6. Hey, what's up, Lizondo? Just doing a little clock synchronization stream here. I don't know if you previously remember, we made this code for getting the inputs from the network from the past that was in that buffer used for packet loss compensation. I think it was 2 streams ago. Yeah. What we did was go through the whole network input history size that we support. We only increment the latest network frame. So maybe here we're just not actually updating this when that happens. Okay. I'm going to not put this here, but what I'm going to try is attach the client here. If we have any crashes, I can find what's going on. But anyway, the host, I'm trying to desync these again. It's really, so what I'm doing is basically dragging. Really? Okay, here we go. Oh wow, I'm getting. Oh, because yeah, its connection got stale. It does insert. This is not actually my library. This is the MBNet library that's doing insert, and that's very frustrating because the connection's getting stale apparently. Wonder any way to fix that. This is not on my code side. This is in the library I'm using. I don't want that to really happen. Ugh, okay. So this is actually messing up my test. Library. This always happens when you're developing stuff. Okay. So instead of the connection going stale, because when I'm dragging the window around, it's not only is it dropping frames locally, but it's also dropping network packets. So to avoid that kind of thing, what engine? This is not any particular engine. I'm just using Raylib, which is a library for doing game development. Okay, so because it seems we have this network library issue caused by not keeping that connection alive, what I'm going to do is add a debug key just to skip the game simulation while I'm holding the button. So let's go back to where's our source file? Here we go. Okay. I'm going to add some debug keys. So let's do, I'm going to go down here just for now. I don't like to dirty up. I like to keep code pretty much organized in things related to. But for now, I'm going to force the game simulation not to update if, is that a value? Yeah, keep pause. Okay. I'm going to force this to be false. And actually, I don't want to go, I want to go to, I want to make sure it's held. So is down. Yeah. So I can pause as long as I want. I could use a toggle, but that's more complicated than I need. Okay. Let's go back. So we can see it's updating on host side, client side. And I'm going to pause. Oh, it's not doing anything? Oh, yeah, there we go. I'll pause as long as I can. And you can see on the left side are that our frame limiting is working here, because it's not updating on this side either. But once I release it, it works again. So clearly, the frame limiting does work. But yeah, you can see how far out of sync we get. 1510 on the net frame and here. So if we close these and well, what's going on there? Yeah, so you can see how skewed it gets. If you get the latest network frame and our frame, you can see how like we got 5 frames ahead. Or 4 frames ahead technically. So anyway, let's go back and change that variable again. Right now it's 5, I think. Okay. So let's restore this again. What is a net frame? The network frame is just the frame we got from the latest frame of input we got from the other player. So if they're at frame 20, it's just 20, right? Or the 20th time they updated their game. It's just a count of how many times they've updated their game simulation. We update our game simulation in this example at a fixed rate. So 1 update per 1/60th of a second is the idea. Okay, did we build that? Let's run this again. We can see this is going on. Let me pause. So we're not completely desynced now. And you can see our frame limit is exactly at 10 here, if you can read that. It's our frame is 363, their frame is, well, yeah. Let me pause it. I usually like to do this with a graph. It takes more time to implement a graph. Yeah, 628 here, 609 here. Oops, I guess I need to keep that clicked. Yeah, we're 10 frames ahead. So 661 here, 665 here, over here at 650, 652. Okay. So we're like skewed right now in time. You can see if I move player 1, there's a delay on this side. If I move the client, you don't see a lot of rollback effects though. It's very subtle. Anyway, I can probably force it to desync if I let it go too far ahead. Give me a second here. Let's just make it really obvious. This is probably going to be caused by packet loss once it eventually does desync. So we simply just don't have the old inputs coming in, because one side has gone so far ahead. So here we go. Let me pause. And you can see how far we've gotten, like 20 frames ahead now. So it seems okay now. If I run a program like Clumsy, which we used last time, to simulate packet loss, we'll probably see the issue here. You always got to check these things with packet loss and network delay. So let's start adding things like lag. You can see it's getting a little choppy here. If I increase it to like 100, it's going to be even more choppy because of the resimulation. Those are rollback effects. Increase it to 200. It's kind of wild now. If you pause, you can see the difference. It's crazy. 70, 43. We're still actually positioned still in sync, so it's still seeming to work. The main reason this is working is that we're not getting packet loss. So let's drop some packets. 10%. Okay, everything's okay here, but let's pause. Now we're out of sync. You can see this. This is caused by dropping packets and not having the input for those frames. Oof. What should have happened though, I don't know why our code wasn't working. If it didn't have input for a particular frame, which it seems like to be the case here, I don't know if you recall, but basically when we don't have input for a frame, we're going to be out of sync if we simulate it. So for now, let's just go back to our frame loader so it doesn't get so far ahead. We might revisit this later, but I want to move on. Okay. We had the debug key, limited how far one side can get ahead. Now, what we're going to do is compensate for the difference compensate for the difference when one player can get ahead of the other. What we're going to basically do is we need to calculate how far we are ahead on our side, and if we're ahead, we want to pause our game briefly to make sure the opponent can catch up. And how are we going to do that? Well, we could use ping. Remember, ping basically is just a round trip time of a packet to get to the other player and back. If we divide by that 2, that's going to be the one-way travel time. So we can assume during that travel time that the opponent's own game client is going to tick forward. So you can add that to the current time you have and assume it would be that far ahead. Or the better way to do it is actually take the latest frame you got from them and add that add that travel time. And you can assume that's basically where they're at. That would be that's one way to do it. But when we're talking about ping, we're talking about like real world time. And that adds another source of input, right? Another source of dependency on a real world clock, or in this case, it's going to be your CPU clock. And those two clocks could be skewed. It's not like skewing isn't an issue. As long as they're ticking at the same rate, it's fine. In the real world, really, it's not going to be an issue, but I don't want to add the dependency. Instead of using the real world clock of your CPU to calculate that round trip time, what we're going to do is use actually the game clock. In this case, what is our game clock? It's just our frame count, right? Each tick represents 1/60th of a second. Even if it doesn't run at that rate, it's still our in-world clock is important, or in-game simulation clock is the most important thing, right? If we run slower, we're going to get behind, and we want to detect whether or not our game simulation clock is run slower. We don't really care so much about the real world. So what we can do is now we're going to take a frame difference, right, of my time and their time, and how many frames we're ahead is going to be affected by latency, right? How long the packet took to travel back and forth. But the most important thing is we want to balance those latencies, right? So what we're going to check to see is the difference between my frame and their frame the same as their frame, my frame, right? Basically, that means the amount of time it took in game time to get their input is the same. In the perfect world, when there's no network latency, that difference would be 0. But in every other case, when it's balanced, that value will be positive, right? And it will be equal if the two games are actually updating at the same frame. If we don't actually update on the same frame, one is going to be when one is ahead and the other is behind. The one that's ahead is going to get those inputs from the other player late. It means their game is going to be more out of sync than the other. And the other basically will see more smooth gameplay. The one that's ahead will see choppier gameplay. So we want to fix that. And we're going to do it by calculating the difference in our frame and their frame and sending it to them. And they're going to send their difference to us, and we're going to compare those values. If our value is larger than theirs, that means we're ahead of them because it's more time that's more time for their inputs to get to us. So we need to slow our game down to basically make those values the same. So we need to add new value to our packet, right? Our package that we send to the other player. So what was it, network package? Oh, sorry, I've already forgotten what we call this thing. Oops. So right now we're just sending a frame count. We also want to send frame diff, frame delta. I'm going to call it that for now. We can change the name later. So when we construct that network package, we don't want to do it in the network, actually. We want to do it in the source file. Okay. So we have the toSend package, and this is where we construct it. Here we're recording the frame count, but we're also going to send the delta of our time and their time. So frame delta equals our current time minus their time. So what was it? I think it's latest network frame. There we go. Okay, so we have this delta here that we received. What we're going to do whenever that delta is ahead of the opponent's delta, we're going to pause. Okay? So what we can do here is let's calculate a latest delta. Let's just store that off for now. Let's just say that's equal to this value. And this is stored here. Because we're going to reuse this value, this frame. We're going to use it to pause our game simulation. Okay, let's go back to our frame limiter. Where was that? Yeah, here we go. So we're of course we're going to limit it in case our simulation is too far ahead, but we're going to limit it if we're too far ahead of the opponent. If we've detected that we're so far a certain number of frames ahead of the opponent, right? So basically, let's just say the local frame delta oh, actually, we need to do one more thing. Not the best comment, but I'm just leave it there. So we need to get the latest input package here. Where was that? And it should be frame delta, right? I've already forgotten the variable name. Okay. Make that a const. Okay. So yeah. So we're going to say if it's greater than some. So basically, this is just checking to see if the values are the same, right? If the delta of our latest local frame delta and theirs, is that right? Yeah. And theirs is more than 0, that means we're ahead of them. But we want some leniency. So let's just give it a 1 frame leniency here, okay? Because we don't want to pause all the time. So if this value is greater than 1, we're going to pause our game simulation. This could be done in any order, but don't worry too much about it. Yeah, so we can test that. Okay, does that work? Yeah, there we go. Cool. So move around is fine. Do we still have the packet loss and stuff going? Yeah, that's all running. So we still have a input delay here. Oops. We got to sync somehow. Let's not worry about that for now. Let's go back to here. Okay, let's reduce that amount of crazy network stuff going on. So let's get rid of drops for now. We got a sync? Okay. Sorry about that. What do we mess up here? This is caused by the network settings? Hold on. That's weird. Okay, it's working here. So, oh man, it went off course. It went so far away. I'm trying to bring it back on screen by looking at these values. Oh, that's weird. I have some bug in my game simulation code. Okay. Sweet. So if I pause this side, you can kind of see where, oh man, you can kind of see where, oh wow, they're taking a head. That shouldn't happen. What did I mess up? Oh. This should be false. Duh. It means I need more coffee. We need to limit the game simulation, so. I need coffee and calories. Okay. Let's do that again. So this should be fine now. We should be paused. Yep, when I pause on this side by holding the pause key, we can see we got this many frames ahead. Okay. So we are limiting the game simulation by by definitely the max frames ahead thing. But you can see they're basically the same value here. It's kind of hard to see the frame differences here to see if the frame we got from them and the frame we have locally is in sync. So I do want to add a little bit of visualization, right? For me, the easiest way to do this is going to be just a simple little graph. I'm going to drop in here. So I don't want to do too much here, but let's go ahead and draw some kind of debug thing. Well, before we do a graph, I'm going to write out that frame difference, right? Okay. So on each side, I'm going to write out local frame delta. So we can quickly view what our local frame delta is on each client and compare them. So you can see on here it's 1 and 0, which makes sense. That's what we expect from our frame limiter. We had like a tolerance of 1. If I pause, you can see it gets auto sync here a little bit while I'm paused. We're at -3 here, -3 there. But because we're detecting that delta, we're detecting the latest frame really quickly. We're not getting that out of sync on the other side. What we can do here is add a little bit of latency, and you can see the frame delta is getting up higher, right? That counts for that round trip time. When you pause now, you can see the local frame delta's got an entire 19 frames behind. I think we're going to be out of sync now. Yeah, so it should not have been 19 frames behind, first of all. Something's wrong with our frame limiter, right? It shouldn't allow it to go that far ahead. Let me restart here and see something. Actually, it might not be our frame limiter. It might be our network code, but give me a second here. But we can see it's our at least our synchronization code is working. We're back at frame 9 or 8 or 10, so we're within a frame 2 window, even when we pause one side, and that happens again. Okay, so we do have a bug. I do want to fix that bug. It's letting our game splitting go too far ahead. But at least I wanted to demonstrate the basic idea of a clock synchronization there. I hope it makes sense. Of course, always feel free to ask questions if you're confused by anything. I know I'm kind of jumping around here a lot more than normal. But yeah, our frame limiter is not quite working the way it should. So what's going on? So let's just double check here. If we are behind the latest network frame we got from them, plus our max number of rollback frames, we're allowed to keep updating. It should work, right? Like, say this will let us go max number of rollback frames plus our latest frame we have from them, right? Why would we get 20 or 19 frames ahead? Indicated by our one side to get 19 frames behind. We can look at that again. Okay. So we just desync there. Okay. That let me try this again. Okay, you can see local frame negative 19, right? And then we get back in sync when I release the pause button. When I hold the pause button, which I'm doing now, I should have like an indicator. Am I pausing or not? Anyway, yeah, you can see how the local frame delta is getting all the way up to like negative 19, which it should never do that. Our global frame limiter should not allow to go that far. Same side on this side. So on the side that we pause, we get that far behind. So what's going on here? The issue is latency. We didn't consider the actual latency that was happening here. We only consider the absolute frame time. We're limiting our frames, right? So if I pause on one side, we get behind by 19 frames. You can see by the frame delta here, negative 19. On this side, well, you can see it's ahead of what it knows by 9 frames, because that's the latest frame it calculated. Isn't that a little weird? It's a little strange, right? Well, there's latency involved. So we need to compensate for that somehow. Give me a second here. I'm going to pull up an example I need to use. I'm just going to reference some code that I have, just double check something. Okay. It should be on this. Should be on this computer. You know what? I'm just going to pull up my own example here real quick on GitHub. Just want to double check something. Okay. No, I don't want to learn more GitHub. Wait, what? I don't get my projects. I get my repositories. Okay. Demo fighter with netcode. Here we go. Let's look at this real quick. Just give me a second, y'all. Okay, that's right. Okay. What are we actually messing up here? If we're limiting the, sorry, it is morning here for me. Actually, I was wrong on this. Latency is not an issue here because if we know the latest network frame from them, we know they at least reach that frame. So we should be able to get at least 10 frames ahead of that and be fine, not be out of sync. But why are we getting 19 frames behind on the other side, though? What's going on there? It's kind of a mystery what's happening at the moment. It's probably some subtle bug here I didn't catch. This caffeine is not strong enough. It might be something to do with how we're actually getting the latest input from the other of the network. It's interesting that one side does indicate that it's only so far ahead, right? So this side says we're 20 behind, but the other side we're only 10 ahead. That should be balanced. Let's stop this real quick. Pause. Okay. If we pause on one side, we only get -3 behind. Oh, we broke something again. I wonder why that's causing a crash there. Let me, you know what? For now, let's attach the process and see what's going on here. Debug. Oops. Yeah. Let's attach to that one. Let's assume the client is what's causing the crash here. I'm gonna pause. It might be the network code again. Since we don't have a lot of latency, everything's fine. Let's add just a little bit of latency. Let's see what happens. Okay. Okay, we can only get so far. I'm hitting pause button. We're only getting up to 7 frames behind here. Okay, let's add 100. So now we're getting too far behind here. You see, we get to -11. Our frame limiter should prevent that. Because the other side shouldn't get so far ahead. But it definitely is dependent on the amount of latency we have here, though, right? So where's the bug? How can we do this starting from beginning principles? Let's just think about this, right? So if my frame count is at, say, 20, and they're at 20, I hold pause button on their side. They stay at 20. I can only get, as long as I know the latest input, I could only get to frame 30, right? 20 plus 10, 30. Or I can, yeah. So I get to frame 30. And they're 20. So the difference should only be 10, right? On their side. They should only see 10. I'm going to turn off this fix for a second, just to exclude the effects of our clock synchronization. And we're only going to use the frame limiter. Okay, so 10, 10, both sides are even. Let me pause on one side. Oops. Well, really? Oh, we're not updating now. Interesting. So 10 is too much. We got to sync with 10. Okay. Well, it does make sense. It should be 10 minus 1. I've mentioned like off by 1 error before. Okay, let's redo this again. Okay, we're updating. We desynced again, really? Why are we desyncing? We should be able to update. What is preventing us from doing that? Let's look at our log real quick. Weird. Hold on. Okay. If I turn off clumsy, what happens? We're just out of sync now. We're not actually updating anymore. It's interesting. Is it the effects of our frame limiter? Well, let's just check real quick. Let's turn off the frame limiter too. Okay. Okay. Great. There's a lot of latency on here. I'm holding the button. It's not updating at a good rate. So what's going on here? It says local frame delta is 1 on each side. It should be much higher because of it's latency. So what's going on? When I turn that off, it's fine. When I turn this, I turned off the synchronization code. So what's going on here? Logo film delta is 1 on each side, huh? What if I pause? I only get so far behind. I did rebuild this, right? That's so weird. Oh, duh. Okay, sorry. I need to force it to always update. Okay. That was a problem. Okay. So we can see we're updating without input. We've got input on this side. It's not reaching this side. We can see the delta is more than 10. Look at the frame delta. It's getting way out of sync. It's getting crazy out of sync. It's so crazy. Look at this. So the delta is never updated. $11.72. Let's do that again. kind of interesting to run into issues like this when you're trying to demonstrate something. It always happens. Okay. Let's turn off the effects of lag for now. And, okay, everything seems okay. It's in sync. But if I pause, we can see the local delta frame time getting super negative, right? And now we're very skewed. We're skewed to the point where you can see a ton of latency. I'll move my character a little bit, and then way later, this one will move, right? It's just simulating the frame way later because of our time skew here. Sorry, I'm fading. I really need to focus more. Okay, this is taking longer than I thought because of this bug. These bugs do happen. You know, the interesting thing here is we're so off our time here. And we're behind so far here. We finally get the input from this side. But if I move it on this side, it's instant, right? That means we're not applying the input on the right frame. Actually, this is a bit confusing. So maybe that's not true. Because our characters stop. Let's think about this a little bit. Because I'm moving the character around. Even though this is so far ahead, as you can see, the frame delta here is 244. You know, even though this is so far ahead, at our current time, when I move this character around, it's gonna be there, and it takes 0 time for that input to travel over the network since we have no latency. And I guess we're just resimulating so fast that it's updating the position instantly, right? Because it's resimulated everything. So it looks like it's being applied on the same frame, but it's not. It's actually going back in time and resimulating. If I had a little bit of latency here, we should see a different effect. It should be delayed. Yeah, as you can see. If I do some packet loss, something similar is going to happen. Well, not enough packet loss, I guess. So anyway, the principles of this stuff is right. It's just buggy at the moment. So we can re-enable the frame limiter again. I really did want to fix this bug where we're getting out of sync if we pause too long. It's taking longer than I wanted, but basically what I showed is what I wanted to cover today. There's a little more I want to do. I want to show how to smooth out desynchronizations, but that's a longer topic. This is just the base principle of the stuff that I wanted to go over, and I don't want to spend too much time on it. So basically, yeah, that's basically it for that stuff. I'm going to spend the next 15-20 minutes fixing this bug. So anybody wants to stick around to watch that, feel free. But I'm not going to talk as much. But yeah, ask any questions you have while I look for this freaking annoying bug. Because I'm doing all this stuff on the top of my head, basically. So, re-enabled all that. We have our latency, turn on lag. We pause. We get out of sync. Get too far behind. Yeah. But we can see if I hold pause and look at our local frame delta, it gets back to a value that's close to the other player, right? So that means the clock synchronization is working as expected. Yeah, honestly, like, Now I think about it, this, even though we have the issues with the higher latencies, like here, when we do synchronization, um, it works for the most part, other than those subtle bugs, which I can cover. But I'm just gonna do that off my off time and demonstrate next time why that bug was occurring. But yeah, so if you have any questions, I'll leave the stream on for a few more minutes. And if not, I'll cut it off. But yeah, that's basically the basic idea how you fix one-sided rollbacks. I'm sorry I didn't have. Unfortunately, the demo here is not really the best one to demonstrate the large effects of rollbacks, right? It's really hard because of that reason I explained, where the position gets updated instantly. It's kind of hard to demonstrate it with this example. I might make a little more simple game later that shows all the issue with it, but something with like a jump arc and stuff like that. But maybe I'll do that until next stream. I think next time I want to cover smoothing out these network synchronizations, because unfortunately, again, with this demo, it's kind of hard to see, but we're kind of jumping back and forth. We're pausing a lot more than we need to, which will cause input loss and stuff like that. We don't have any like input buffers in this game. It's just direction moves the character. But yeah, you can see where our deltas are basically staying the same. So this is the idea of fixing one-sided rollbacks. It's not too difficult. The issues, of course, you can introduce bugs at higher latencies that you need to compensate for. That we definitely have an issue with the frame limiter. It should be working, but I probably have some subtle bug somewhere that's like a one off by one error that's causing the one client to get so far behind, or at least think it's very far behind. Oh, I think I know the issue. One side is getting ahead, but the other side, for some reason, it's not thinking it's getting the inputs yet, right? It's somehow thinking, the inputs are there. It should be able to simulate, but it can't simulate, so it can't update its frame. Okay, so anyway, I'll look at that later, and I don't know if anybody's still around, but thanks for coming by. Thanks for coming by, of course, and yeah, until next time, peace out. Appreciate y'all dropping by, and have a good night.